Hello, my name is John North. I'm a senior economist with Fastmarkets REIT. Today, I'm going to give a brief presentation on sustainable aviation fuels, specifically looking at raw materials or the feedstocks that are used in sustainable aviation fuel production. Currently, there are 4 technologies that are in various stages of development to produce SAF. The first one is the hydroprocess esters and fatty acids process. Next is gasification, alcohol to jet, and then power to liquid. While HEFA might be the most common, today what we're going to focus on specifically are the feedstocks that are proposed to be used in gasification and alcohol to jet. As you can tell, both technology processes have very similar feedstocks. You can see agricultural residues, forestry residues, herbaceous energy crops. There's a lot of commonality between those two. And that's what I want to focus on today. And specifically, we'll talk about the role that forestry plays in producing feedstocks for SAF production. Now, obviously, sustainability is already baked into the name, sustainable aviation fuel. And so there are some preferred feedstocks to be used, and there are some that are far less preferred. In the old days especially of road biodiesel production in the United States specifically, there was a lot of corn that was used to make corn-based ethanol that was used to be blended into diesel and make road biodiesel. And regulators and politicians tried to make the case that if you planted corn specifically for use in ethanol, it was going to put upward pressure on corn that's eventually used for food. So ultimately is going to result in higher prices of food. And that's something that the SAF community sort of seeks to avoid. So if you look at the top of the slide there, you see the first generation feedstocks, and that's all the virgin vegetable oils, palm oil, soybean oil, corn oil, that type of thing, as well as sugarcane. And down in Brazil, there's a pretty advanced sugarcane-based ethanol road biodiesel market that is doing quite well, but at the same time, there's a lot of questions around land use of sugarcane specifically to make road biodiesel, but still a market that works nonetheless. But what I feel like the sustainable aviation community is seeking to avoid is incentivizing the use of something like palm oil, which would incentivize further oil palm plantations in places like Indonesia and Malaysia that are facing mass threat of deforestation from large companies that are planting and expanding their oil palm plantations. So while at one point those feedstocks may have been preferable for processes like the HEFA process and things like that, today's sustainable aviation fuel community is trying to get away from incentivizing stuff like that. And really what they seem to be focused on are the second classification, which are the advanced feedstocks as well as the waste feedstocks. So we've already talked about how the HEFA process uses cooking oil, it uses animal waste fats and other waste lipids, which means that that feedstock has already been used for its primary use. So like used cooking oil, used in the restaurant industry, used at Kentucky Fried Chicken, and then once it's past its usable date, it can be recycled and then used as a feedstock for sustainable aviation. So that seems to be the goal that SAF producers are trying to go for. But there's also, as more technology, the technological pathways become more and more developed, there's also these purpose-grown energy crops. So there are, the inedible oil-based or oil-producing crops like carinata, which can't be used in food because they're inedible, but they produce an oil that can be used to be turned into SAF or some type of biodiesel. And then there are other things like ag residues, forest residues, which we're going to talk a little bit more in depth about, that either they don't currently go to a market, or the market's not that strong, or they're just not used at all, and could be used potentially for SAF production. The bottom part of this slide is feedstocks that are for the very, very, very technologically developed processes, specifically power to liquid, which again is very, very early in its infancy. But from a sustainability standpoint, once that technology has been developed, I mean, capturing CO2 from the air, I mean, it really doesn't get more sustainable from that than that, rather. But today we're really going to focus on the advanced and the waste feedstocks. As with everything that's got the sustainable tag, you know, there has to be a certification body, and in this case, the Roundtable on Sustainable Biomaterials is the leading body for certification of SAF, and they've worked very closely with the International Civil Aviation Organization as well as the International Air Transport Association, and they developed this thing called CORSIA, or the Carbon Offsetting and Reduction Scheme for International Aviation. Obviously, the carbon footprint of commercial aviation is quite large, and there's just a ton of political and of social pressure to reduce carbon emissions, to reduce greenhouse gas emissions. And this is just one way that the aviation community is looking to do that. But in order to ensure, that they're not incentivizing, just massive deforestation of tropical rainforest in Indonesia in order to plant more oil palm plantations, in order to prevent things like that, they've developed this pretty rigorous criteria that is really based on 12 principles. And as you can see, I mean, it runs the full cycle of cultivation of the feedstock to its harvest, to its aggregation, to processing, transportation. I mean, just really the entire life cycle of these feedstock productions. I mean, it takes into account things like human and labor rights, land use, just really everything. They want to be the Roundtable on Sustainable Biomass and this CORSIA scheme really wants to be sure that they're not putting disincentives out into the market or causing these unintended negative consequences by by incentivizing the use of things like used cooking oil or ag residues or forestry residues. So they want to make sure that this is a net positive gain on greenhouse gas emissions reduction. So given where we stand with technology today, again, the HEFA process is the most common, it's the most cost efficient, and it takes advantage of, it requires basically lipids to be used as feedstock. And as we can see, over the next 4 to 5 years or so, we suspect that used cooking oil is going to be the primary feedstock, as well as palm fatty acid distillates, which are a byproduct of palm oil production. And that's going to encompass about 3/4 or about 3/4 of total production in the next couple of years or so. But with that said, we believe as the other pathways become more prevalent, as they become more financially feasible, feedstocks are going to have to adjust to meet those technologies. And if you'll remember from the second slide, gasification as well as alcohol to jet, they were quite reliant on things like forestry residues and agricultural residues. Sometimes feedstocks that do have secondary markets, like for ag residues. I think I brought up the example earlier of the sugarcane sugarcane-based ethanol market in Brazil. It's not always just the raw sugarcane that's used. It's the bagasse or the waste after the sugar and the liquid have been extracted. You can still use the bagasse to make biodiesel. So the same type of thing exists in forestry. There are some residues from the harvest process, from wood products manufacturing, from the pulping process that could potentially be used as feedstocks. And again, we kind of want to focus on a little bit of those today because we feel like they've got almost the most room to grow in the coming years. So again, while used cooking oil is the primary feedstock used today, I don't want us to cover it too much. I know my colleague Ryan Standard from the Jacobsen will be giving a great presentation on UCO as he follows the market much more closely than I do coming up. So that's why I wanted to kind of stick to more of the forestry stuff. But as you can see, we suspect that especially on the ag side, but even to the same degree, the forestry side, we do think that there's growth in the potential feedstocks that are going to be available in the coming years as those SAF pathways become more and more and more developed. And if you look kind of at the bottom, UCO and other waste lipids, it kind of speaks to, it seems like there's a little bit of constraint on that market. We don't know how much it's really going to grow relative to to forestry and ag residues. And there's also some growth in other things as well, municipal solid waste, the cellulosic cover crops and that type of thing. But again, that's very dependent on the technologies being further developed and becoming more economically viable. So we'll go ahead and start with a little bit of the bad news on the forestry side. The forestry industry as a whole is quite efficient. There is very, very, very little that is wasted. And so if you look at the chart starting to the left, you can see that things like recovered wood, bark, and sawdust that are byproducts of either the harvesting process or wood products manufacturing, those residuals have secondary markets. They're either gone, they either can be used to make, they can just be burned as is to create energy. They can be made into pellets, which are then again burned to create energy. Things like sawdust, for example, can be used or is used rather in particle board manufacturing. You also have things like residual chips left over from a sawmill that's used in panel production, that's used in medium density fiberboard production. So the forestry industry is quite efficient. There's not a lot of waste. There's money to be made across the value chain, and so that's incentivized use of almost everything. With the exception of really one thing, if you look in the middle of the graph, you can see that there's logging residues and there's stumps, and there's no black check mark under any of under the graph there to show that those items are specifically dedicated to a particular use. You can see that there's kind of a lightly colored gray check mark under logging residues to be used in energy and pellets. And that's because we are hypothesizing that some harvest residues that currently do not really have a widespread in-use market could potentially be diverted if the policy is worded correctly to SAF production. The graph on the right really just speaks to how well established some of the biomass energy, pulp and paper, wood products manufacturing type industries already are. So again, I've kind of started with these headwinds that forestry is facing when it comes to being a potential feedstock for SAF production. But just to kind of give you an idea of the ability for those established industries to pay for these type of residues, especially when you get into the pulp side, packaging side, they're quite strong. So it will be difficult to divert some of these feedstocks away, but we do think there's potential in logging residues as well as stumps. So a current estimate on the potential of this market, the wood residue market, roughly 665 million dry tons. And a lot of that, like I said in the previous slide, is already spoken for. This just gives you probably maybe a better visualization of where those residuals and residues end up going. I think I mentioned earlier, from a sawmill, there are chips left over that get sold. If they're of the right quality, they can get sold to pulp producers. If they're of a lesser quality, they can get sold to medium density fiberboard, panel producers. And if it's actual sawdust, it can get sold to particle board producers. So again, there are all these secondary and tertiary markets that do exist for a lot of these residues, and you can see that with byproducts from the actual pulping process itself, the black liquor that is often burned on site for energy for the mill. There's also this thing called crude tall oil that we'll talk about that could be made into biofuel, but there's really not a lot of it. And then there's bark, and there's other wood waste that's in the recycle chain that could be used as well. It just sort of depends on if the proper incentives are in place to divert it away from these other markets. So again, carrying on with the headwinds that SAF producers face in trying to incorporate forestry feedstocks. As I mentioned, right now, residuals from sawmills and other wood products manufacturing a lot of times go into wood pellet production, which is a market that is growing pretty significantly and has been doing for the last a little less than a decade or so. But wood pellets are a very hot commodity right now. A lot of the production takes place in North America, and most of those volumes are exported to Europe, to Drax in the United Kingdom, whose demand has grown every single year for the last decade. Demand is growing in Asia, especially in South Korea and Japan. The latter is turning away from nuclear energy and looking at really incorporating woody biomass. So this wood pellet market is pretty well established. And so this is just an example of some of the competition that SAF producers would face. If you look to the right, prices have been somewhat stable, but you can sort of tell into the early part of 2021, there's been a pretty significant upturn in prices as this market continues to grow. So just giving you a sense of some of the competition that SAF producers will face when they're looking to forestry feedstocks. Same thing on the crude tall oil side. I briefly mentioned this earlier. So crude tall oil is a byproduct of the softwood kraft pulping process. And as far as softwood kraft pulp mills go, there are only really a few in the world, not a few, but just they're sort of concentrated. So there are quite a few mills in Scandinavia, Finland, Sweden, Norway. There are some in North America, some in Latin America, and a few in Asia, though not nearly as many. Basically, the point being is that crude tall oil would be an ideal feedstock for something like the HEFA process. Just the unfortunate piece is just that there's not that much of it. There's already secondary markets for crude tall oil. It's used in processes to make other chemicals. It's actually used in paints. So it's got other markets to go to. Some of it's actually burned on site at the mill for energy. But again, kind of the point being is that it'd be a great feedstock, but there are some other uses for it. And then at the end of the day, there's really not that much available globally. So we've dispensed with the headwinds that these type of forestry feedstocks would be facing, and now let's get into the tailwinds. So there are some byproducts from the actual harvesting process. So when a tree is to be harvested, those of you in forestry know, the feller buncher, this big massive machine goes out, cuts it at the base. In most cases can debark it on site, definitely delimbs it, and then cuts off the top, and then cuts it into smaller usable logs, either for the pulp mill or the sawmill, depending on the diameter of the log. But with that said, there is some waste. And there are three different types of waste that come from the harvesting process. That's slash, stemwood waste, and then the actual stumps and roots that are very often left in the ground. Now, as you can see here, or rather, as you can probably imagine, we'll start with the stumps and roots. That is very, very, very expensive to extract. And often it's just left in the forest to decompose. There's an ecological benefit to leaving it, but really the reason it's left is because it's so expensive to extract. But the point being, there is a lot of potential energy that's being left in the stumps and roots that are often left in the forest. But at the same time, something that's much easier to collect, though we don't have a cost-effective process by which to collect it just yet, but things like stemwood waste and slash. I mean, this is just stuff that either a sawmill or pulp mill can't use, and it doesn't make a lot of financial sense to get out there and actually collect it, aggregate it, do whatever needs to be done to get it to a market. So often it's just left. It's actually just left on the forest floor. So you can see we tried to quantify that in our estimate of extraction, especially on the stemwood side, is you could collect 100% of that because it all just gets left out in the forest. So if we could find these ways to collect this stuff, there certainly is a lot of potential energy that's being left in the forest. So just a quick example, and we use the example of Sweden, which we'll get into a little later about why we use Sweden. But as you can see, the annual forest growth is around 200 million cubic meters, and you can tell there's growth that's not harvested because it's not it's not the right age class, so it's left to get bigger. And then there's the annual harvest, around 158 million cubic meters a year. But then you can see that there's about 66 million cubic meters of those harvest residuals that we discussed earlier, the slash, the stemwood, and the stumps that are actually left in the forest. Now, we show in this case that actually a lot of the stemwood is actually used in industry, and that's because Sweden is one of two countries that already has a market for these harvest residuals. So as far as I know, they're the only two countries in the world that actually go out and collect these harvest residuals to be used for energy, typically in co-fired heat and power plants. So just to extrapolate that particular example that we gave in Sweden, if you look at the total industrial roundwood harvest in 2019, that was the latest date that the data was available. The total harvest was over 2 billion cubic meters in 2019, and presumably it's roughly the same each year. But if you extrapolate some of the planning factors that we had for things like slash, stemwood, and stumps, you can see that there's almost 600 million cubic meters of these harvest residuals that are just left out in the forest. Again, because it's not cost effective, there's not a strong enough market out there to go pick this stuff up, basically, with the exception of Sweden and Finland that does a pretty good job of it. But the point being is that, once gasification and alcohol to jet become more financially viable, there's a lot of feedstock out there for them. We just have to then further develop technology to go out and actually collect all of this harvest waste. So this is just an example of the market that does currently exist in Sweden, and you have to understand that this actually is on a very, very, very micro level. So these harvest residuals that come from the forest that are collected, they're not transported very far from the forest. A lot of the heat production as well as energy production in Sweden is done in a very localized, a very micro sense. So from a financial perspective, it makes sense to go out and collect these things because they don't have to be transported all that far to eventually make it to a CHP style plant where it can be burned. And really the cost per megawatt hour is actually quite low relative to the rest of the world. Now, it would become problematic if the CHP plants in Sweden were more spread out and transportation costs were a little bit higher, then this probably would not be as viable. But as it stands right now, Sweden does make this work, and Finland does the same thing as well. again, these CHP type plants are on a very localized type level, and then thus their cost per megawatt hour for these feedstocks is very low. So this is something that we think, depending on technology development for both SAF production as well as technology development when it comes to collecting and sorting and aggregating these harvest residuals, we think that these markets could be replicated outside of Sweden and Finland, and in other countries, maybe like in Germany, where there's there's some SAF production, there's some SAF producers in the United States. Like these type of markets could exist in other places should the technology become available. And so we'll wind down with finally some good news. I've made reference a couple of times to the reason that harvest residuals are not collected is because the technology just doesn't exist to make it financially viable. We actually spoke with some researchers in Finland, some forestry researchers in Finland as well as in Sweden, who wrote a paper. You can see it's linked below, or at least the reference is below. Published in 2016. However, the research is ongoing, and they looked at basically what it meant to develop these type of markets that go out and collect these harvest residuals and then feed them to a biomass power plant, either to a biomass power plant or then to a biofuel type producer. And I would tell you that certainly distance had a lot to do with it. I think I alluded to that earlier. The further you take it away from the forest, the higher transportation costs, the less economically viable it becomes. And you can tell from the exponential rise in the graph there that once you get sort of over a certain distance, that it becomes not viable pretty quickly. So with that said, I think the most interesting thing here is the last bullet, which is more integrated forest harvesting systems. Not only are being developed, so not only are they there to to harvest the tree and take the most valuable part of the tree, but it would also incorporate collecting some of these harvest residuals as well, which are normally just left out in the forest. But as that becomes more viable, then forest residues as a feedstock would become even more viable for SAF producers. So again, quite long-winded. We do believe that forestry residuals will be a viable feedstock as technology becomes more and more developed. It's something that SAF producers we really think need to look at. So with that said, I will stop there. There's already been a million plugs, I'm sure, for this all-encompassing study that I was a part of with some of my colleagues from Fastmarkets, as well as our partners at O'Kelly Acumen. We just recently put out this full spectrum report on sustainable aviation fuels. The link is right there if you're interested. If you have any questions for me about how forestry fits into this piece, please feel free to contact me. I'm available at any time, and I really appreciate your attention and hope to see you all in person at some point soon. Take care.